name is Desmond Edagese, and I welcome you to mathematics class. Today, we'll be looking at the theme, algebraic processes. And our topic for today is Algebraic Fractions, Part 1. Now, here are the things that we'll be learning in our class today. So first, we'll have a brief introduction to what algebraic fractions are. I know you already have an idea. We'll just get to refresh our memory. Secondly, we'll learn how to simplify algebraic fractions. And finally, at the end of our class today, I expect you to know how to carry out operations in algebraic fractions. It promises to be an exciting class. Are you ready? Let's go on. Now, before we go on, let's remind ourselves, what is an algebraic expression? An algebraic expression is a mathematical statement that contains ordinary numbers, variables such as x and y, and operators. Our operators add, subtract, multiply, and divide. So that's what an algebraic expression is. Now, what are algebraic fractions? Of course, we know what fractions are. An algebraic fractions, therefore, is simply a fraction whose numerator and denominator consists of algebraic expressions. Let's take some typical examples. So we have 8n all over 3v. This is an example of an algebraic fraction. 6y all over x plus 1 is another good example of an algebraic fraction. And also 4b squared all over 2ab. These are all examples of algebraic fractions. Now we'll go on into our class and we'll see how we can simplify these algebraic fractions. Now, to simplify algebraic fractions, there are basically two simple steps. Quite simple. First, you factorize the numerators and denominators if needed. When we factorize, what happens? We have simpler expressions to work with. And then next, we divide our numerator and denominator by any factor that they have in common. Now take note, in the course of our lesson today, we'll find that sometimes the signs of our numerator or denominator may change. When they do so, take note that the sign of the fraction itself is changed. Let's take some examples. Now, if you have a all over minus b, okay, the negative sign is attached to our denominator there. It is also equal to minus a over b. Of course, this negative sign is attached to our numerator, but this is the form in which it is put. So we say it is minus a over b. Now, the minus affects all of our expression there, a over b. So we'll find out in the course of our class how to manage such changes in sign. Now let's take some examples so we better understand how to simplify algebraic fractions. Take this first example here. Reduce this algebraic fraction to its lowest terms. So we have 6bd all over minus 9ac. So we see an example of what we just talked about. Our negative sign is attached to our denominator. We bring that up and we rewrite our algebraic fraction like this. So we say minus 6bd all over 9ac. Now that we've done that, we can go ahead to reduce our fraction. Next, we find a factor that is common to both the numerator and the denominator, and we divide or we cancel out of our fractions to get a much more simplified fraction. Now let's take a look at our fraction. We have 6bd, 9ac. bdac, there is nothing common, but 6 and 9, of course, we have something common. 3 can divide into 6 and also divide into 9. So we do that. The common factor is 3. We divide the top, which is 6, by 3 to get 2. Divide 9 by 3 to get 3. And we have a simplified algebraic fraction, which is minus 2bd all over 3ac. That's quite a very simple one. Let's take something more complex. Now, if you were asked to simplify 6x squared y squared minus 4xy cubed all over 9x cubed y minus 4xy cubed to its lowest term. How would you go about doing that? Reminding ourselves of the steps we learned earlier, we said the first thing to do is to do what? Factorize the numerator and the denominator. So let's go ahead to do that. Factorizing our numerator, okay, 6x squared y squared minus 4xy cubed. What do they have in common? We find that 2 can go in 6, 2 can also go in 4. So we have a common number. Also, look at the variables, x present, x also present, y present here, y also present here. So we have them also as common factors. We take out our x and we take out also our y. But notice that our y here comes in power 2 and also comes in power 3 here. So a common power would be 2. So we have a common factor. We take that out and then we write the remainders that we have in the numerator. That's 3x. That is, if we take 2x y squared out of this, what do we have left? We have 3x left. And also on this side, we have 2y left. So we've been able to factorize our numerator. Next, we also factorize our denominator. 9 and 4, all right, they are not common, but x and y, they are common. So we have our common factors. We take that out. Okay, when we take that out, what do we have left? Our 9 is left. And we have x squared also left. Minus 4 remains. And then we have our y squared. So we've been able to factorize. Now, the next step is to go ahead to further simplify. In simplifying, we'll see that there are still other ways to factorize this further. All right? We have, for instance, here 9x squared minus 4y squared. This can be further broken down. So we break that down to be xy. Okay, we have 3 common there, 3x plus 2y. Okay, so we have our denominator here further factorized, which we have here. Okay, now that they are neatly laid out, let's confirm to see which factors are common so that we can easily divide out. We have that 3x minus 2y is present in the numerator. Also look, 3x minus 2y is also present in the denominator, so we cancel that out. Okay, and what do we have left? 2xy all over x squared or in bracket 3x plus 2y. So that's a simplified version of our initial algebraic fraction. Now let's take some more examples. Simplify this fraction here. C squared minus CD all over D squared minus CD. Again, following our 2 steps. First, factorize the numerator and the denominator. To factorize our numerator, okay, we take out common term, which is C. We have C there. All right, and what's left within the bracket is C minus D. For our denominator, D is also common. We take out D, and then we leave that in the bracket, the remnant, which is D minus C. Now, this brings to play the part we learned about our negative sign changing. All right? Our intention is to ensure that we have factors that are common in both the numerator and the denominator. But now we have, let's read it out, C, all in bracket C minus D, all over D, all in bracket D minus C. C minus D, okay? D minus C can be written in the form of C minus D by changing our operator there. Let's see how. Now, if we take our negative sign out, remember this negative sign is attached to the C, okay? So we say C minus D. D is positive, C is negative. In rewriting this, if we take our minus outside, what do we have? We have our C still remaining negative, and our d becoming positive because minus times minus will give us a positive value. So it's the same value as d, all in bracket d minus c. Now we have common factors. C minus d in the numerator, also we have c minus d in the denominator. Now we can easily cancel out. So we cancel c minus d and c minus d. What do we have left? C all over minus d. That's our common factor. We have c all over minus d, but we said instead of writing it that way, we write as minus c over d. So that's a situation where we have a change in the sign. Let's take another example. If you are asked to reduce m squared minus 5n plus 6 to its lowest term. Again, first factorize the numerator and the denominator. So in factorizing our numerator, m squared minus 5n plus 6, all right, we'll find two numbers when multiplied will give us our value there. When added will give us our value here. That's factorization. Those numbers are minus 2 and 3. So we say m minus 2 and m minus 3 is the factorized version of m squared minus 5n plus 6. In factorizing our denominator, we do the same thing, and we have what? 2 minus m, 1 minus m. So we have factorized versions of our initial expressions. Now, we can see again that we have factors that can be the same when we change the signs in our numerator. Notice you can change the sign either in the numerator or in the denominator, depending on how you want to do it. So in this case, we're going to change the sign in our numerator. Let's go ahead to do that. So we have m minus 2, okay? We write that as 2 minus m. Taking our minus outside. So we take this minus outside. Notice our minus 2 still remains the minus 2 that it was initially. Our m is positive. Of course, it's not shown, but it's positive. And our negative sign multiplies minus m to give us that same positive. So m minus 2 is same as saying minus 2 minus m. Okay? Our negative sign here, minus 2, still remains. The positive m, the minus also multiplies minus m to give us back the positive m. So it's just a different way of rewriting, okay? So we have 2 minus m, m minus 3 remains. And beneath our denominator, we have 2 minus m, 1 minus m. So now we have been able to carve out common factors. Common factor here is 2 minus m, so we cancel 2 minus m out. Our negative sign remains, this remains, this remains. So we have this as minus m minus 3 all over 1 minus m, which we have there. But again, since we already know how to change signs, instead of leaving this in this form, you can also rewrite this in another form so that they look similar. Here we have minus in bracket m minus 3, and here you have 1 minus m. So we can make it in such a way that our numerator or our denominator looks similar to the other. If we change the signs in our denominator, m will come over here, and the number goes over there so that they look like the top. To change 1 minus m, okay, again, remember, our minus m is negative, our number there is positive 1. We say minus, okay, we bring m to the front, so our minus m remains, and then we say minus 1. Minus times minus will give us back our plus 1 that was here. So this is just another form of rewriting it. So we've rewritten 1 minus m as this. We have minus m minus 1 as the denominator, whereas our numerator is minus m minus 3. So our minus cancels minus. And that's why we have m minus 3, m minus 1 It's just same values, but a different way of rewriting it. So that's how we make use of our negative signs to position our expressions in the way that they should be. Now, we'll learn how to carry out operations in algebraic fractions. So we have operations such as subtraction, multiplication, addition, division. Let's start with the addition and subtraction of algebraic fractions. Now, to add or subtract algebraic fractions, we follow 3 simple steps. Step 1, so find the LCM of the denominators first. Secondly, express each fraction with the LCM as a denominator. So in this case, we need to find out equivalent fractions, basically, okay, in order to get fractions that have the same denominator. I'm sure you remember how to find equivalent fractions. And finally, we simplify, that is, we add or subtract the numerators to obtain the numerator of our resultant fraction. Now, let's take some examples. Simplify 6 over a minus 3 over 2b. 6 over a minus 3 over 2b. To do this, we said, first step, find the LCM, okay, of our fractions. So what do we do? In this case, we directly multiply our denominators to get 2ab. So 2ab becomes our LCM. Now we express each fraction with 2ab as our LCM as its denominator. Now, to express each of our fraction with LCM 2ab as its denominator, what do? These are the steps we follow. We multiply 6 over a, all right, times the denominator of the other fraction here, which is 2b, both at the top and below also. So we multiply top and bottom by 2b. 6 over a times 2b over 2b basically gives us 6 times 2b all over a times 2b. All right? If you notice, we have common factors that we can easily cancel out. Again, on the other side of our fraction also, we multiply 3 over 2b times the denominator of the other fraction, a, top and bottom. So we have 3 over 2b times a over a, which gives us 3 times a all over 2b times a. All right? So we have, in this case, 6 times 2b gives us 12b. A times 2b gives us 2ab. 3 times a gives us 3a. And 2b times a gives us 2ab. So we've been able to achieve what we wanted, to express each fraction with our LCM as a denominator. So we have 12b all over 2ab minus 3a all over 2ab, same denominators. All right? We could call them equivalent fractions. Next, what do? We go ahead. Since we have same denominators, we can easily do our operation, which is a subtraction in this case. 12b minus 3a is our numerator, all over one common denominator, 2ab. This becomes our simplified expression. All right, let's take another example. Simplify 1 over p minus 2q plus 2 all over p plus 3q. Same steps in this situation again. Find the LCM. Okay, the LCM again in this case is a simple multiplication of our denominators, p minus 2q multiplied by p plus 3q. So that gives us our LCM. Again, to express each of our fraction here, okay, with this LCM as our denominator, what do? We said multiply the first fraction, okay, which is 1 over p minus 2q, 1 over p minus 2q, times the denominator of our other fraction, top and bottom. So we multiply that. We have p plus 3q all over p plus 3q. That is 1 over p minus 2q times p plus 3q all over p plus 3q. And that gives us 1 times p plus 3q all over p minus 2q times p plus 3q. The other fraction also we have is 2 all over p plus 3q. We also multiply top and bottom with the denominator of the first fraction. So our second fraction becomes 2 all over p plus 3q times p minus 2q all over p minus 2q, top and bottom. All right, which gives us, of course, 2 times p minus 2q all over p plus 3q times p minus 2q. Okay, so we have our fractions, okay, expressed in this manner. Now we have p plus 3q, and then we multiply p minus 2q, all in bracket p plus 3q. That, of course, is our LCM, and that is what we sought from the beginning. Plus 2 multiplied by p minus 2q gives us 2p minus 4q, all over p minus 2q, all in bracket p plus 3q. Of course, this is our LCM. So we've been able to achieve same denominator, and that denominator is our LCM as agreed earlier. So what do we do next? Now that we have same denominators, we can easily carry out our operation, which is a plus. We simply add p plus 3q to 2p minus 4q. So we have p plus 2p gives us 3p, okay? And then we have minus 4q plus 3q, which gives us minus q. So we have 3p minus q, and then all over LCM, which is p minus 2q, all in bracket p plus 3q. This is the simplified form of our initial expression. Quite simple if you follow our steps. Next, we'll be looking at the other operations that we have, multiplication and division. How to carry out multiplication and division of algebraic fractions. Now, to multiply or divide algebraic fractions, what do? You follow 2 simple steps, similar to the steps that we've been following so far. First, factorize your numerator and denominator if necessary. Second, divide the numerator and the denominator by any factor that they have in common. Now, let's see some typical examples. Simplify m plus n all over m times mn all over 3m plus 3n. So first, we said factorize the numerator and the denominator. All right? When we do that, what do we have? For 3m plus 3n, which can be factorized, 3 is common, so we take 3 out. And then we have in bracket left m plus n. So we've been able to rewrite 3m plus 3n in its factorized version as 3 all over m plus n. Now, take a good look at our expression there. What factor is common? Because the next step is to find out the common factors so that we can easily divide them through. We have m plus n on this side, and we have m plus n also. So we have common factors. Also, m is another common factor we have here. Within this product, mn, m is also visible or present. So we have things to cancel out. We'll go ahead to do that. M plus n, okay, from the numerator cancels out m plus n in our denominator. That's 1. M in our denominator also cancels out the m in our numerator. So what do we have left? We have n, all right, and we have 3. So when we have divided through, what we have left is what? N over 3. So we've been able to simplify that to give us n over 3. Now, take a look at one that is a little bit more complex. Okay? Operations in divisions of algebraic fractions. Let's see. H squared minus a squared all over h squared plus bh plus ah plus ab divided by h squared minus 2ah plus a squared all over ch plus bc. Now, to do this, there's something we must take note of. When it comes to operations in divisions, okay, when you say divide a fraction by another, what you're saying is multiply the first fraction by the reciprocal of the other fraction. So let's call this A and call this B. All right, so we're saying when you say A divided by B, okay, what it invariably means is that you're saying A times the reciprocal of B, that is 1 over B. So you have A over B, all right? So in the same way, when we carry out division operations in algebraic fractions, we take note of this form here. So h squared minus a squared all over h squared plus bh plus ah plus ab divided by all of this becomes h squared minus a squared all over h squared plus bh plus ah plus ab times the reciprocal of our expression here, which becomes ch plus bc all over h squared minus 2ah plus a squared. So now that we've rearranged it, okay, what do we do next? We factorize our numerator and the denominator. H squared minus a squared, factorize to become h minus a, all in brackets, plus h plus a. Also, h squared plus bh plus ah plus ab is also factorized to give us h plus b, all in bracket, h plus a. ch plus bc is factorized. C is common, so we take c out to give us c, all in bracket, h plus b. And h squared minus 2ah plus a squared is factorized to give us h minus a, all in bracket, h minus a. Now we have common factors. If we take a look at our expression here, okay, h minus a is common. We have it in the numerator, we have it in the denominator. H plus a is also common. We have that in the numerator. We also have that in the denominator. And h plus b is also common. We have that in the numerator here, and we also have that in our denominator. So we cancel out every common factor, and we'll see what we have left. H minus a in the numerator cancels out h minus a in the denominator. H plus a in the numerator cancels out h plus a in the denominator. H plus b in the numerator cancels out h plus b in the denominator. And what do we have left? We have c and we have h minus a in the denominator left. So when we have divided through, we have c all over h minus a as our answer. Wow. And with that, we've come to the end of our class today. But before we go, we'll take a quick look at some of the things that we have learned today. We learned that algebraic fractions are fractions whose numerator and denominator consist of algebraic expressions. And we said some examples are 8n all over 3v is an example, 6y all over x plus 1 is another example, 4b squared all over 2ab is also an example of algebraic fraction. We said to simplify algebraic fractions, what do? We factorize the numerators and denominators, and then we divide both by any factor that they may have in common. We also learned how to carry out operations such as addition, subtraction, multiplication, and division, following simple steps that were outlined in the course of our class. Now, to be sure that you have truly learned how to factorize algebraic fractions, we'll take 2 quick exercises and then we'll end our class for today. So, exercise 1. Simplify d squared minus 9 all over d squared minus 7d plus 12. So, following our steps, we said factorize the numerator and also factorize the denominator. Factorizing our numerator, d squared minus 9, simply gives us d minus 3, all in brackets, d plus 3. All right? Also, factorizing our denominator, d squared minus 7d plus 12. Of course, to factorize that, you'll find two numbers that you can multiply to give you plus 12, and at the same time add to give you minus 7. All right? Those numbers are minus 3 and minus 4. So we write that down. We have d minus 3 and d minus 4. Now we've been able to lay out our expression in a clear manner. What do we do next? We find common factors, okay, and then we cross them out or we divide through by those common factors. Look at our expression carefully. What are the common factors? We have d minus 3 as a common factor. It is present in the numerator. It's also present in the denominator. So let's cancel out. We cancel out, and what do we have left? D plus 3 all over d minus 4. Let's see which of our options here have our correct answer. Is it A, B, C, or D? Option C is our correct answer. I hope you got it correct at home. Also, now let's take our second question. Simplify c squared minus cd all over d squared minus de divided by d squared minus cd all over cd minus ce. Again, following the steps that we outlined, first, we said since we have an operator that is a division sign, what do? We multiply the first expression by the reciprocal of the second expression. Okay, reciprocal simply means the bottom becomes the top and the top becomes the bottom. So we take whatever is in the bottom up and we take whatever is in the top down. So let's do that. We write this expression as c squared minus cd all over d squared minus de times the reciprocal of our second expression, which is cd minus ce all over d squared minus cd. All right? Very good. So what do we do next? Next, we factorize our numerators and our denominators. So let's go ahead to factorize c squared minus cd. C is common. So we take c out and we have what's left in our bracket as c minus d. d squared minus de. D is also common. So we leave that d minus e within the brackets multiplied by c is also common in our expression here. So we take that out. And what do we have left? D minus e. Again, for our expression there, d is common also. We have d minus c. So we have c all in bracket c minus d over d all in bracket d minus e times c all in bracket d minus e all over d all in bracket d minus c. Now, talking about what we learned earlier about signs changing, all right? Our intention is to get factors that are common so that we can cancel out. We already have d minus e as a common factor. But note, c minus d, d minus c can become common factors if we do the arrangement or the rearrangement of signs that we learned about earlier. All right, so let's try and rearrange our signs. If we rearrange the sign in our denominator there, we would have, let's just take that out here. What we would have is, we take the minus sign outside, and then we have c minus d. Just as a check, remember, our minus c, okay, still remains a minus c. And our d, which is positive here, still remains minus, and minus d remains a positive d. So it's correct. So we can rewrite that as minus d, c minus d. So if we do that, let's see what it would look like. We'd have that d minus e times C D minus E all over. Now we have minus D, okay, C minus D. So now we have two common factors, D minus E and C minus D. Let's cancel that quickly. C minus D cancels C minus D. D minus E cancels D minus E. And what do we have left? We have C over D multiplied by C over minus D. Okay? If we multiply out, we'll have what? C squared all over minus D squared. But of course, we said instead of writing this sign in the denominator or even in the numerator, you write it to cover the whole fraction. So we have that as minus C squared all over D squared. And that becomes our answer. Minus C squared all over D squared. Now let's see which of our options here has the correct answer. Is it A, B, C, or D? Option B is the correct answer. So guys, I'm sure you've learned quite a lot. Remember what I always say, practice, practice, practice will make you a better math student. Till I see you next time, it's bye-bye from me.
If you enjoyed this video, hit the like button, drop a comment, and subscribe to our channel. You can also turn on notifications to stay updated on new videos on this channel. This Brain Friend video was brought to you by SynForest. For more of these amazing e-learning videos, get your copy of Brain Friend. With more than 1,000 e-learning videos, over 74,000 test items in more than 40 subjects, a career counseling guide, and many other amazing features, BrainFriend remains your foremost e-learning and exam preparatory software. BrainFriend. Learn better, make excellent grades.